Okay, so we left off talking about how to convert between fractions and decimals. Sorry about the examples with area and volume there. That's something coming later in the course for you guys. Um, Today I want to talk about one of the more useful concepts in math, one of the most broadly applied concepts in math. It's actually part of ratios and proportions. What we're going to talk about today is just a little piece of that, and that is percents. Understand how percents work. It helps to understand what the word percent is. It's actually two words. Per, if you think of miles per gallon, miles per hour, dollars per hour, it means for each or out of. And cent, which means 100. So percent means out of 100.
What are you going to do, Wade?
So if we want to work with a percent, if we're given something like 34%, what that literally means is 34 out of 100. In fact, if we want to convert a percent into a fraction, it's just that easy. We put it over 100. Now, of course, as a fraction, we wouldn't leave it like that. We would want to reduce. Both 34 and 100 can be divided by 2. 34 divided by 2 would be 17, and 100 divided by 2 would be 50. Let's look at some examples of converting these percents into fractions. Let's do 65%. Now, of course, 65%, again, it literally means 65 out of 100. As a fraction, of course, we are going to reduce that. Both 65 and 100 can be divided by 5. 65 divided by 5 is 13, and 100 divided by 5 is 20. And that's as far as we can reduce that one. Well, not all of our percents are quite that easy to reduce. We can run into something like 324%. Well, again, that still literally means 324 out of 100. Now, one of the first things you might notice here is that that's an improper fraction. The numerator is bigger than the denominator. So we can do 324 divided by 100 and get it into a mixed number. Now, I usually do that conversion here before I start to reduce, because dividing by 100 is pretty simple. We know that goes in there 3 times with 24 left over. So this will be 3 and 24/100. Now I'm going to start reducing the fraction portion of that. 24 and 100 both divide by 2, but some of you might see that it both divide by 4. 24 divided by 4 is 6. 100 divided by 4 is 25. And we can't forget the 3 for the whole number. So 3 and 6/25. Let's take something like 36 2/3%. Now, we don't like having fractions within our fractions, but this literally does mean 36 2/3 out of 100. But we want to do something with that. We want to get that fraction out of the fraction, so it's just a simple fraction rather than that's what we would call a compound fraction. There are a couple of ways we can go about this. The first way is to use common denominators and multiply numerator and denominator by that common denominator. Now, by common denominator, I mean within each part. Here, this is the thirds And this is ones. There is no real denominator there in the bottom part. So if I do that, I take my 36 2/3 over 100, and I'm going to multiply by 3 on top and bottom. That'll get rid of that denominator there of 3. Well, 36 2/3 times 3, I have to do 36 times 3 is 108, plus 2 is 110, over 3 times 3 over 1. Remember, when we multiply by a whole number, a fraction by a whole number, we put it over 1 to make it a fraction. The 3's cross cancel out, giving me 1 and 1. That multiplies to be 110. Well, 100 times 3 is just 300. Both of those will reduce by 10, because they end in zeros, giving me 11/30. The second method, method 2, is I could, especially since we have calculators that divide fractions for us. Remember, we've mentioned that fractions and division problems are kind of equivalent. We can convert back and forth from one to the other. So I can just take that as 46 2/3, instead of being over 100, as divided by 100. Now, of course, I'm going to make that 100 over 1, so I'm dividing by a fraction. Now I have to do two things here. I have to make that improper fractions rather than mixed numbers. So 36 times 3 is 108, plus 2 is 110 over 3. And I have to change it to multiplying by the reciprocal. So times, instead of 100 over 1, it's 1 over 100. Now both 110 and 100 can divide by 10 because they end in zeros. 110 divided by 10 is 11. 100 divided by 10 is 10. And we do 11 times 1 is 11. 3 times 10 is 30. 11/30. Any questions there? Okay, we might have 56.25%. Again, that literally means 56.25 over 100. Now, we said in the previous example we didn't like having fractions within our fractions. We don't like having decimals within our fractions any better. So we need to get rid of the decimal. Now, when we were dividing decimals and we wanted to get rid of the decimal, we counted the number of decimal places and we multiplied by 10 or 100 or 1,000, whatever we needed to get rid of it. Same thing happens here. There's 2 decimal places here. To get rid of 2 decimal places, I multiply by 100. Of course, since that's now a fraction, I have to multiply both the numerator and denominator by the 100. 56.25 times 100 is 5,625. And 100 times 100 is 10,000. Now these can be reduced. Both of those can be divided by 25. 5,625 divided by 25 is 225. 10,000 divided by 25 is 400. Well, they can still be reduced. Actually, both of them can still be divided by 25. 225 divided by 25 is 9. 400 divided by 25 is 16. That reduces to 9/16. So 56.25% is 9/16, or 9 out of 16. Now, we mentioned that these percents actually are part of ratios. So technically, this is not 9/16 as a fraction. It's 9 out of 16 as a ratio. Same with these up here. 36.2% or 36 2/3% is 11 out of 30 as a ratio. In your notes, I'm going to have you try a few here. Let's do 285%, 18 1/3%, and 37.5%. 37.5%. convert those three into fractions, into that fraction or ratio form in your notes, and we'll talk about them here in just a couple minutes. So for the first one here, we'll see how far you got. If you're not all done, completely done, that's fine. 285%, of course, is 285 out of 100. Easy to turn that into a mixed number there. 100 goes into 285 twice with 85 left over. Now we'll reduce the fraction portion. Both 85 and 100 divide by 5. 85 divided by 5 is 17, and 100 divided by 5 is 20. And of course we keep the 2. For the second one here, 18 and 1/3%. That's 18 and 1/3 out of 100. Now I think the easier way of the two, we could multiply by 3, but I think the easier way to handle it is just to divide. Treat this as 18 and 1/3 divided by 100. So that'll give me 18 times 3 is 54, plus 1 is 55/3. Divided by 100 over 1 is the same as multiplying by 1 over 100. We can cross cancel. 55 and 100 both divide by 5. 55 divided by 5 is 11, and 100 divided by 5 is 20. And then we have 11 times 1 is 11. 3 times 20 is 60, so 11/60ths. And finally, our last one, 37.5%, is again literally 37.5 over 100. We need to get rid of the decimal. There's one decimal place, so we'll multiply by 10. So 37.5 times 10 is 375. 100 times 10 is 1,000. Both of those can divide by 25 again. 375 divided by 25 is 15. 1,000 divided by 25 is 40. And we can still divide both of those by 5. 15 divided by 5 is 3. 40 divided by 5 is 8. That's 3/8.
Sorry, could you explain to me again why you would multiply by 10? Where does 10 get in there?
Okay, we have to get, good question. We have to get rid of this decimal place here. There's only one decimal place. So if I multiply by 10, it moves that decimal point over and it gets rid of the decimal. If there was 2 decimal places, we would have multiplied by 100 and so on. 3 would have been 1,000, whatever. So multiplying by the 10 is just moving the decimal point over a spot so that we don't have decimals within our fraction.
Okay.
Next, then, is converting our percents into decimals. If I go back to my 34%, we already said that that literally means 34 out of 100. Well, to turn a fraction into a decimal, we just divide. 34 divided by 100 is 0.34. Now we could do that division quickly because dividing by 100, just like we saw multiplying by 10 or 100 moves the decimal point, dividing by 100 just moves the decimal point. It moves it over 2 spots. So if I have 72% and I want to convert it into a decimal, remember if there's no decimal point written, it's at the end of the number. To turn it to a decimal, we move it 2 spots to the left. That becomes 0.72. Now, we're used to this being called decimal form, or just turning it to a decimal. And it kind of is, but there's actually another name for it. It is called a rate. A rate is a decimal form of a percent turned into a decimal. And when we look at our calculations with percents next week, we'll see where that rate comes into play. So if I have 29% as a decimal, I move it 2 spots, it becomes 0.29. If I have 240%, converting that to a decimal or a rate, that decimal point moves over 2 spots, that becomes 2.4. If I have 6%, I have to move that decimal 2 spots. That is 0 because there's not enough places to move it. I get 0.06 as a decimal. 3.1%, same type of thing. I have to move the decimal 2 spots, but there isn't enough digits, so I have to add a 0 there to get 0.031 as the decimal form or the rate form of that percent. Now, the one that always catches people is this one, 1/4% as a decimal. Most people would say 0.25%, but that's not true. 0.25 would still be a percent. 1/4 is 0.25, but this is a percent. 1/4% is 0.25%. I have not changed it into a rate or a decimal yet. I just changed it into a decimal form still as a percent. To make that now a rate, I still have to divide by 100 or move the decimal point over 2 spots. So that becomes 0.0025. One thing I'm going to talk about more later in class is something called benchmarks. And benchmarks are like your estimating that we talked about when we were using the calculator to add, subtract, multiply, or divide. For a benchmark, one of the common benchmarks is 1%. And as a decimal, we know 1% is 0.01. And we use those benchmarks to compare other things to, answers to, in other words. If 1% is 0.01 as a decimal, we look up here, 1/4 of a percent is smaller than 1%. If 1/4 of a percent is smaller than 1%, its decimal form or rate has to be smaller than the 0.01. So the 0.025 makes sense. Oh, sometimes I need to switch from that decimal back into a percent. Well, we said this is called a rate. 0.23 as a rate means 0.23 out of every 1. A rate is called a unit rate. It's out of 1. Well, we want it to be a percent, which would be out of 100. So we would multiply the 1 by 100, and we'd multiply the 0.23 by 100. Well, 1 times 100 is just 100. 0.23 times 100 is 23. That's 23 out of 100, or 23%. Well, when we go from that decimal or rate into a percent, we're always going to be just multiplying by 100. So every time we multiply by 100, the decimal point moves 2 spots, just the opposite of dividing by 100. So 0.23, we can just move it over to become 23. If I have 0.71 as a rate, I move the decimal 2 spots, it becomes 71%. If I have 0.3 as a rate, I move that decimal, I've got to be careful. I don't have 2 spots to move it, so I have to add a 0. That becomes 30%. If I have 0.074 as a rate, to turn that into a decimal, I have to go 2 spots, into a percent, I have to go 2 spots. It's 7.4%. And the one that most people screw up is if I have something like 2 as a rate. That's a rate. To make it a percent, I still have to go 2 spots. I'm going to have to add zeros to go those 2 spots. That's 200%. Remember, 100% equals 1, or the other way around, 1 as a rate equals 100%. So 2 was bigger than 1, so it's going to have to be something larger than 100%. Just like up here, down here, 240 was bigger than 100, so the rate's going to be bigger than 1. Well, our last big function here is converting our fractions back into a percent. Let's start out with one that we all know. Most of us know that 3/4 is 75%. Pretty simple. If we didn't know that, we have a couple of routes we could have taken. We could have turned it into a decimal. 3 divided by 4 is 0.75. And then we could have moved a decimal point. 1, 2 makes that 75%. Or the other way we could think about it is 3/4 can be thought of as a ratio, 3 out of 4. Remember we said our percents are really a ratio. And we want it to be out of 100. Now when we look at this, we have to figure out what do you multiply 4 by to make 100, and that's going to be 25. So we do 3 times 25 is 75. So 75 out of 100, which is 75%. Now, not all of them are that simple, where what you multiply by to get 100 is straightforward like that. We can run into ones like this, 5/8. Looking at that, we don't immediately just see what you multiply 8 by to turn it into 100. But if we look close, if we can't figure that out by just looking at it, we can calculate it by going backwards. Instead of figuring out what do you multiply 8 by to make 100, we go 100 divided by 8 equals that number. That's 12.5. That's what we have to multiply the numerator by. 5 times 12.5 is 62.5. 62.5 out of 100, or 62.5%. Now, there's a shortcut that came out of this. To fill in the number that's in the numerator up here, we took 5 and we multiplied it by that 100 divided by 8. Well, and we've done other things where we've fudged the order of operations. I can take those parentheses out and just do it like that. 5 times 100 is 500, divided by 8 is the 62.5. Well, rather than writing this in here, we've come up with a shortcut for that. And that is, we know that this number here is going to get multiplied by the number that is diagonal to it. We call that cross multiplying. And then it's going to be divided by the number underneath it, the 8. Call that and divide. Notice it was 5 times 100, that's the cross multiplying, then divide by 8. So if I have 2/5, and I want to turn it into a percent. So out of 100, it's simply 2 times 100 is 200. That's my cross multiply. I always multiply the two numbers that are diagonal with each other. And then the other number is what I divide by, divided by 5. 200 divided by 5 is 40. That's 40 over 100, or 40%. Now, I mentioned something called benchmarks. Common benchmarks, we saw 1%, but the other one is also 10%. So if I have a number like 328, that number represents the whole thing, or 100%. 10% of that is 10 out of 100, or 1/10. We just move the decimal point, 32.8. It's always real easy, really quick to find 10%. You divide by 10 or move that decimal point one spot. 1% is just as simple. It's 1 out of 100, or 100th. So we could find that by moving the decimal point 2 spots. That becomes 3.28. Well, we can use those benchmarks when making calculations. If I ask you to find 12% of 328, and you come up with an answer like 29.1, you know that's not wrong, not correct, because 10%, we just saw over here, is 32.8. 12% has to be larger than the 10%. Can't be smaller. So we know something went wrong in that calculation. So that is not correct. Well, the benchmarks can actually be used to find that 12%. If I wanted to find 12%, I could write that as 10% plus 1% plus 1%. We know 10% is 32.8. 10% was 32.8, 1% is 3.28, and another 3.28. If I add those up, well, 10 plus 1 plus 1 is 12%. Here we've got 16, 13, carry the 1, 9, and 3. 39.36 is actually 12%. Now, we're going to look at methods for being more direct in how we calculate that coming up in our next class. But for right now, those benchmarks are a quick way to estimate those percents. And as we move into the actual calculations, it's going to help us to double check our answers. Anybody have any questions? So quiz 4 is out there. Quiz 4 is on decimals. I'd like you to complete and submit that by noon tomorrow, September 4th. So that's on Blackboard. Please look into that and get her to me. Homework. Looking in the big book. Page 218. This is in the unit exercises. 1 through 23, the odds. Converting percents from one form to another. I realize we still have like 17, 18 minutes left, but I usually give you 10 or 15 minutes to do the quiz in class. I'm not going to take that time away from you just because you're logging in from home. You're free to use the last 18 minutes here to either start the homework or work on the quiz, whichever you want. If you want to stay on the network, I'll be here to answer questions. But if you want to log out, that is okay too. Anybody have any questions so far? Okay, I will end the recording, and you guys have the last.